Now, where's the reviewing this? We have, for example, this vector. You have the tail here from 100 to 011, right? So the first thing to remember is that we are going to use the right-hand coordinate system to determine the coordinates. In this case, you have this point, so you have 1, 0, 0, 1 because here is 1 in X, 1 cell unit to this side. You have 0 in Y because you're here, and you have 0 in Z because you are here. 2, 0, 1, 1. 0 because you are practically in 0 in X, but you are 1 in Y and 1 in Z. Okay, so knowing that, the next thing is to subtract the tail point coordinates from the head point coordinates to obtain the number of lattice parameter units in each axis direction. So we're going to subtract these coordinates from these coordinates, right? So we're going to have this operation. So 0 minus 1 minus 1, 1 minus 0, 0, 1 minus 0, 0. No, 1, I mean. So you have this. Eliminate fractions. In this case, we don't have fractions. So in this case, apply this point. And at the end, we need to write the numbers between crochets. And if we have a negative one, we're going to add a small line over the number. We saw this the last class, right? I think. Yes.
Yes.
Okay, well, so today we're going to practice some exercises of these vectors. So let's try to do this. I'm going to help you with this. Let's try to do it together. This first example here. We have what's the coordinate for the tail in this case? What's the coordinate? How much in X?
1/2.
Okay, so then in Y?
1.
And in Z?
Also 1.
Okay, so now here in the head, what's the coordinates? What are the coordinates in this case? How much? No. What's the value for X?
1,
1 for Y?
0,
And the other one?
1/2.
Very well. So we're going to do the operation head minus tail. So you have 1, 0, 1/2, and this minus 1/2, 1, and 1. So 1 minus 1/2, you have this, you have this, and also minus 1/2. Okay, now because we have fractions, we need to eliminate the fractions. So the thing that we usually do is to multiply these by 2. So you're going to obtain 1 minus 2 and minus 1 again. So you have 1 minus 2 and minus 1. Okay, so at the end, the mirror index is going to be 1, 2, well, negative 2 and negative 1, right? Very well. Now, let's practice another one. Questions till this point? I think no. So let me erase this. And let's continue with other exercise. Okay, so we have this. The mirror index is here. Now, the next one, the red one in the right. What's coordinates for the tail and the head? Start from the tail. What's the coordinate for this point? Zero, really? If you move
1,
from
1, 0.
yes, yeah, yes, this one. So 1, 1, 0. Okay, and in the head, what's the value? This point.
0, 0 and half.
Let's check. 0, 0 and a half. Let's see. 0, yes. The other one also. Okay, very well. So let's calculate the mirror indexes. So you have 0, 0, 1 half. And this minus 1, 1, 0. So you're going to have minus 1, and 1 half. You have also a fraction. We need to eliminate by multiplying by 2. So you have at the end minus 2, minus 2, minus 2, minus 2, and 1. So the mirror index for this is going to be this one. Try to write the examples, please, because it's going to be in an assignment in Schoology, right? All these 8 exercises. Very well. Let's continue with the red one, this one. The Miller indexes, please, for the tail and the head. Tail is going to be what? 0, 1, 0. Okay. The other one? 1, 0, 0. Okay. Very well. So at the end, the same operation. You have head minus tail, 1, 0, 0, and 0, 1, 0. So at the end, you're going to obtain, let me write this. 1 minus 1 and 0. So the mirror index for this is going to be 1 with this thing, and 0. Okay. So if you don't have questions, as homework, you're going to solve the rest of the exercises. You have 5, right? I think it's quite easy to see. Now, there's the second part of the exercise. In this case, you have to obtain the mirror index. In the other case, you're going to draw the vector. And you're going to establish the coordinate systems as your convenience, right? So you have the mirror index. In this case, you're going to trace the vector. You have in the right-hand side the instructions or some rules that we need to see to follow to draw that vector. So one of these is to divide through, so all the numbers are less than or equal to 1 in the unit cell. In this case, the first one, you practically have that condition. Okay. Then sketch unit cell, you need an additional negative unit cell. But to avoid drawing additional unit or negative unit cells, you can move the origin along each axis that has a negative index. So practically you can move the origin wherever you want. You could place it here, you could place it here. It depends on the case. Let's check the instructions. In this case, because you have 1, 1, 1, practically it's not necessary. Yeah, you don't have negative values here, so it's not necessary. So divide, well, we have already done this. Also this, you have here the sketch of the unit cell. Now start from the origin or the tail coordinate and move along x direction based on the first index. So because we don't have any negative number here in the Miller index, we can place the axis or the origin here. So from the origin, then we're going to move as we have here. So you place here C, you have X, and you have Y. So it says, move along X direction based on the first index, this one. So we move 1. Now we are here. Well, let me. From the origin, we move 1. Then move along Y direction based on the second. So it says 1, 1. Move along Z direction. In this case, it's 1 also. So here's going to be the head. So you are going to trace the vector like this, more or less, right? I think it's quite easy to practice. Okay, so you have the tail and you have the head here. So that's the exercise in this case. Let's check the second one, this one. Let me see who's in this. Okay. Now, I was in this. Okay, so let's check that one. In the first case, divide through, so all the numbers are going to be less or equal to 1 in terms of unit cell units, right? In this case, you have that condition as in the beginning, so there's no problem. So then, sketch unit cell, and to avoid drawing additional negative unit cells, move the origins along each axis that has a negative index. So in this case, we have a negative index in X. So we're going to move the origin from here to here, could be, right? So now the origin is going to be here. Why? Because we need a negative X. You have here this negative. So the second one, or the next step, starting from the origin, move along X direction based on the first number. So you have -1, right? So from here, -1 in X. Then 0 in Y. So we remain here. And move along Z direction. In this case is 1. So we move here. So the vector is going to be this one. Where's the point? This is here. So we move from he moved from the origin to the point in the head, right? You're going to do this in your notebook using ruler and that stuff, so you're going to have better drawings than mine. So, questions till this point, how to solve the next homework exercise, I think is quite easy also. Questions?
I have a question.
Tell me.
With the number 3, what we're going to do?
Let's check. Divide through, it's the same instruction. So practically, the thing that you're going to do is to divide these by 3. The reason is the highest number, and you need to have values less or equal to 1. So in order to obtain that, you need to divide all these by 3. So the mirror index, or the original mirror index, is going to be 0, 1/3, and 1, right? So it's the same operation. Because you have positive values, the origin remains in the same place as the other one. So we have Z, you have Y, and you have X, right? So following the instructions, we have the sketch of the unit cell. We have identified the origin. If you have positive values, the origin remains always in the same place that we usually use. But if you have negatives, you're going to move the axis in terms of the number of units that you have here. So that's why in the previous one, we moved the origin from here to here. But in this case, because it's positive, it remains in the same place. So from the origin, we're going to have here the tail. We're going to move along direction, X direction. In this case, it's 0, so we still are going to be here. In Y, you have 1/3. You need to identify 1/3. So you have more or less here. So you move 1/3 in the Y axis, and in Z you have 1. So you move here. So the head is going to be in this point. So something like this, right? Now, I think this is clear how to manage when you have values different from 1, right?
Yes, thank you, teacher.
Okay, another question? As you can see, the homework is easy. So you have to have in your notebook written all these exercises, those that I did, and also the rest. Very well. So if you don't have questions with this exercise, let's check. Well, there's some answers from your classmates of the other group. Let's check now the planes. In the case of planes, you have the same same pathway. We only have some little differences, but it's going to be practically the same. So in terms of planes, or the reason or the importance of tracing the planes in these unit cells is because depending on the planes, you're going to have different properties in the materials. So as we saw in the tensile test slides and that stuff, we said that elongation or comparison between aluminum and magnesium, one of the main features of why aluminum has more elongation than the other one is because aluminum has FCC structure, and FCC is going to be moving in planes like this. So these planes permit some mechanical properties or differences in mechanical properties. And also the planes are going to be useful to identify crystalline structures using X-ray diffraction. So in order to obtain the Miller index for a plane, in this case in cubic cells, we're going to, as a first step, we're going to identify the points in which the plane intersects crystallographic axis. And if the plane passes through the origin must be moved to an adjacent unit cell. In this example, you don't have this case. So we need to identify the points in which the plane intersects crystallographic axis. So here you have one point, the other point, and this one. So the intersection in C is going to be in 1, the intersection in X is going to be 1, and in Y also is going to be 1. Very well. So having identified all these points, these, and these, we're going to take the reciprocals of each value. So the reciprocal of 1 is going to be 1 for each value. So we have the reciprocals, and then the next step is going to eliminate fractions, but in this case we don't have. We have only 1. So we're going to write the numbers between crochets. In this case, not crochets, it's going to be between parentheses, right? Like this. And if you have a negative number, you're going to do the same thing. You're going to add a line over the number, right? Questions in how to assign a Miller index in a
Integers.
plane, I think
Integers.
it's quite clear. Let's check another example.
Integers. Integers.
Now you have this. The same thing. Identify the points in which the plane intersects crystallographic axis. In this case, as you can see, the plane intersects in the origin. So, because we have that, we need to move the origin to an adjacent unit cell. In this case, we move the plane to an adjacent unit cell in the backside. So we have now this. Now, let's identify the intersections. As you can see, the plane is going to intersect Y at the value of -1, because here you have the origin, right? And because we don't have intersections with X and C, because the plane is parallel to that axis, we're going to add an infinite symbol to represent that. So the intersections are going to be infinite for X and C because they are parallel to the plane, and -1 in Y, right? So the reciprocal, as you saw in derivatives, 1 over or divided by a huge number is going to be practically 0. 1 over -1 is going to be -1, and 1 over infinite is going to be also 0. So, as in the other case, we don't have fractions, so we only write between parentheses the indexes. So you have 0, 1, or -1, and 0 here, right? Questions till this point? No. Okay. Yes. If you don't have any intersection, then that point of intersection is going to be represented by this one, right? Yeah, because as you move in the axis, you don't, in any time, you're not going to touch that axis with the plane. So that's why we mark with this value, right? Okay, another question? No? Or yes? Well, let's check another exercise. No, yeah, another example, right? So now we have this plane. So the same thing, identify the points in which the plane intersects crystallographic axis. And if the plane passes through the origin must be moved to an adjacent unit cell. In this case, we have the intersection of the plane in the x-axis in this value, in 1. In the y-axis, you have 1, you have 2. The intersection is going to be in 2. Remember that we're moving in terms of unit cell units, right? Or parameter, lattice parameter units. So y equals to 2 of the intersection. And as you can see, the plane is parallel to C. So because there's not going to be never an intersection, C is going to be infinite. So here we have the intersections and the parallel of the plane. So taking the reciprocal, you have 1 over 1, you have 1, 1 over 2, 1/2, and 1 over infinite is going to be 0. Now, we have the fraction. We do the same operation as taking in Miller indices for vectors. You multiply and you obtain this. And the rest is to write that between crochets. And if you have negative, you add the line, right? So it's quite easy. Now, you have another homework, this one. So let's try to do the first exercise and then you do the rest. So we establish the axis here. So tell me, what's the intersection of this plane in the rest of the planes? What do we need to see or to check here? We're going to have what? Let's check again. This or this one, probably. Let's try to see. Let's check the plane coordinates. For this point, you have 0, 0, 1, right? So you have an intersect of C here. You think you're going to have an intercept in Y? Probably not. And the intersection in X, how much is going to be? You need to think on that. So, as homework, you're going to you saw how to do this and the rest of the examples. So please, what's the word? We need to solve these, the other 3 homeworks, and also this. This is going to be for the next class, not as homework. Homework is going to be only till this slide. These slides are now in Schoology, so you can check it if you want to print and to draw and that stuff. You're free to do that. I'm going to give you an assignment to upload this homework, right? Because now it's 9:50. And we're going to continue all this stuff of the Miller indices and that and X-ray diffraction the next week. So let me call the roll. And then you may leave. Okay. Now, okay, you may go. Have a nice weekend and see you on Monday, right?
Right. See you,
Thank
teacher. Thank you.
See you.
See you, teacher.
See you.